Edition of 3D Printing News Unpeeled, courtesy of 3dprint.com. And today we're talking about the 3D Systems ProJet MJP 2500W Plus. That's quite a mouthful. It is a printer that makes 100% wax casting patterns. It's very different than what we used to have when a lot of these things were photopolymer only, and that would mean that the casting house or the processing company that did this would have to change its formula, or would have to change the way it did business, or change its oven temperatures, things like this. And now they could just use wax, um, they used to, and then when they make these things the classical way. Now, of course, SolidScape and others, and also other systems, have been making these wax casting patterns um, for a long time now, and 3D Systems has other printers capable of doing something similar. And again, this isn't a revolution, but the thing is, that is exactly the point. The point of what I want to, the reason why I'm talking about this particular system is there's no flashbang, incredibly new thing about this. We've been doing wax patterns for a time. This NJP technology has been around for a time. These types of printers have been around for a time. This kind of use as wax casting patterns in jewelry and other industries has been around for a time. But what we're seeing in this system is a gradual evolution. It's an improvement of the system. It's a just better one, right? So we've got a doubling of vertical resolution. There's less finishing, less labor costs, which is particularly of interest now. And also there's a reduction of just waste material, especially metal waste material, thanks to the improvements of the printer itself. So the company says it can produce really sharp edges and good level of detail, which is really important. And the throughput is 25% higher than compared to previous systems. So what we're seeing here is just a system that is just better and better for industry and better for the people that buy it, and more cost effective for the people that buy it than the previous one. And we don't really, in my opinion, really, spend enough time talking about these gradual improvements, and this is the stuff that'll get us there, right? It's not some whiz bang new technology. When we usually see it, brand new printer, brand new technology, most of the time it doesn't work, right? Or it'll take a long time for it to work properly. And this is the type of stuff that'll industrialize us, just going from a printer that kind of works to one that works better, to one that works even better, and one that works like that. And that's why I want to point this out. And again, this is also stuff that people want, right? Better surface detail, less finishing, right? Less labor, sharp edges. These are exactly the type of things these casting guys want. So this is absolutely fantastic. I think it's one of the things we don't spend enough time on. We often don't remember that the Model T wasn't the first car. And also, in talking about the Ford story, it seems like the assembly line is really the key innovation. Well, the assembly line is a very important innovation, but there were a lot of cars that laid the groundwork and were improving. And at one point, there was a car that at a price point made through a system that was efficient, that was developed enough, and this market was developed enough for the Model T to become the success it did. And I think we kind of forget about that. We're always looking for the next thing, and sometimes it's just a gradual evolution of a new thing. So that's what we see here, and we just see some of these casting patterns that they're making look really, really good, and I think that's very, very good. And this is a system that this technology, essentially, humankind has been using for over 5,000 years as an exhibit the other day when we're looking at like ancient Hindu kind of sculptures and statues and things that are using exactly the same technology, only without the 3D printing. But this is a gradual evolution that has taken us a very, very long time, but can get us to a lot of parts. We must not forget that there are tens of millions of parts being made in the jewelry industry, and we don't talk about it enough as well. The next thing is something about Rosswag Engineering. Now, Rosswag it's a 3D printing service bureau, metal 3D printing. You can also pay them to qualify parts for you if you wanted to, or materials or things like that. What you can also do, they have a kind of this marketplace function where you can buy settings for them. So for a particular material, they have the optimal settings and you purchase them, which I think was a really innovative idea. They also supply powder, so they're a bit hard to characterize, and that's the reason I like Rosswag, is because everyone else is just, I'm a service bureau, this is what I do, right? Or you're a service bureau and do something on the side. And Rosswag does a lot of stuff on the side, and it really is kind of monetizing the IP that is generated to do its work. And I think that's very exciting. So they have a thing called AMiquam or AMiquam or something like that. AMiquam. I'm not entirely sure how to pronounce that. This is essentially an eddy current based direct non-destructive testing part monitoring system. And it's wireless. You can put it in your metal printer. The idea is that you can do that either with the help of your metal printing company or independently of them, depending on how well you get along with them and what you want to do. and it'll help you in speeding up your qualification processes and making that less painful, and maybe saving you a couple hundred coupons left or right or center. Now, I love this because it's an AM tool made by the industry for the industry. It's an AM tool made by a bunch of experts that are using this every day to qualify their parts. And these guys really are in the qualification business. They're really good at qualifying new materials and parts and stuff like this. So this is something they use. And this is now something they're offering to the rest of us. And I think this is wonderful. Now, qualification, of course, is, it's painful. But I don't think we realize just how painful it is because of just how much money it costs us to take this machine offline for X amount of days or weeks or something like that, and to take our best people offline as well and have them work on this every single time. But think about this. Imagine I had a dual laser system and I'm happily printing on this, and now you adopt a quad laser system. You're my direct competitor, let's say. I'll say you're Swiss 212 and I'm Optisys or something like that. All right, you adopt the quad laser. I then also adopt months later the quad laser system. So we're kind of then like stuck in this eternal battle of trying to get the latest technology. The quad laser system is much more productive, much more lower cost per part. And then all of a sudden, like, where does it all end? No, but think about this. Imagine that you had this technology or a bunch of software technology and stuff that allowed you to qualify parts and systems and standardize parts and dial in, if you will, settings and parts and things much quicker than me. It would take me 8 weeks, let's say, and would take you, let's say 4. You would perennially have a head start. You would perennially able to adopt these technologies much quicker. It won't only save you 4 weeks. That's also going to make you up and running much quicker. It's allow you to get to the market quicker. It allows you to ramp up production quicker. So you're building in a permanent advantage because every machine generation we're going to keep doing this. So I think that qualification is not only this painful thing you do once, which a lot of people think of it's like this painful thing you do once for a material, for a part or whatever, and then you just keep churning them out. But it's something that can give you edge. It can give you a competitive advantage over other people if you qualify faster. And I think adopt new printers faster, adopt new technologies faster, but also new settings, right? Imagine you have a new setting dial in that allows you to print 20% faster. You could adopt that. In some cases, maybe I couldn't adopt it because I don't have the people or I don't have the time to stop printing to adopt it, right? So I think it's a really key, and I think this is a beautiful tool, or it's a beautiful idea. I don't know if it really works well. I'm sorry, I haven't talked to anyone that has it yet, but yeah, I want to see more tools like this by the AM industry for the AM industry. People saying, "Hey, I use this at my work. I do this a lot, and it's better because of it." Selling out to people who are going to be doing this as well. And also, just to me, qualification, adopting, and speeding up that process is a really, really, really important thing. Much, much more important than most people think it is. Or most people think it's important to get the parts right and get the parts flying and stuff like this. But I think it's a source of competitive advantage if you can do it well and quicker. The next thing is, well, this is one of those newfangled things where we don't really know how long it's going to take for this to sweep down into the factory floor. But it is research by the Max Planck Institute of Medical Research and Heidelberg University. And they're using, it's a paper by Kai Melde, a whole bunch of other people, and it's called Compact Holographic Sound Fields Enable Rapid One-Step Assembly of Matter in 3D. Now, sound 3D printing, as of course everyone is going to term this, has been done a little bit before, right? There's research on this in the bioprinting realm. Mimics Biotherapeutics have done this. What they've done in this case is one shot, right? They're calling one shot or in one take, if you will, or in one movement, if you will. 3D printing of silica gel beads in this case, using shaped ultrasound. What they're doing is structured interwoven sound fields, right? Where multiple ultrasound beams come together and focus together to create an object in one step, if you will, right? So it's kind of like this hollow kind of processes we've seen. There's holographic type of processes that we've seen before, the light-based holographic processes. It's a simple, like, we print the entire object in one field of view, if you will. And we align, in this case, all these beads, right, into one solid object. Now, that's wonderful. The team self thinks it's something that can be used for bioprinting, for example. I'm very excited about this for a different reason, and that's because of this voxel fab idea, this voxel fabbing idea, and voxel level manufacturing. And Neil Gershenfeld and a bunch of other people have been working on this for a long time. And that's his whole idea, is that you have these little voxels, and they can have different properties. Some of them can be magnetic, some of them can be metallic, less metallic, some of them can be rigid, some of them can be less rigid, all that kind of stuff. And you organize them in a certain way, and then you then print them in a certain way, all right, to get an object, right? The added advantage of these very, very tiny voxels can change the properties across the part in a gradient type of way, but also in kind of novel ways where we can make something not only more flexible in a certain area, but also more or less magnetic, for example, or more and less magnetic in certain zones throughout the object and that kind of thing, softer as it goes magnetic. We can do tons of different stuff, even change properties into ways that we have not even considered yet. And to me, in the abstract, the voxel fab idea is really nice. But there's very few practical technologies where you're like, well, okay, if you give somebody like $100 million in 10 years, they could get there, right? The vision is there, and we're taking baby steps, but we're not there. We're not even like at the proto FDM, we're in that kind of thing. We're not even there like, oh yeah, that plus a decade will get you there. But to me, this ultrasound 3D printing kind of thing is a particular technology that could organize a lot of these individual voxels in a very quick way into a shape that could very well work. So that's the other particular reason why I'm very excited about this. Anyway, this was our news for today. I hope you enjoyed it. I hope you found this useful. Keep reaching out with ideas, suggestions, news items, that kind of thing. My name is Joris Peels. This is 3D Printing News Unpeeled, and this is courtesy of 3dprint.com. You have a great day.